So here we have the 2014 higher level short question A4. So what we have been given when we read the question is a Sabutio figure, which is the hemisphere, and we're also shown the football, and the two of them are in contact with each other. We're told that the sphere is A and the hemisphere is B. So that's our football and that's our Sabutio man down in a little diagram that is shown to us. So what we've been asked to do is we're told that they're in contact with each other, and part A of the question just asks us to complete the plan of both solids in contact. So we're already in the elevation, we have the elevation. In the elevation we have the sphere. So in this case all I'm going to do is simple orthographic projection, where the center of the sphere is in one view. Of course it's going to be directly underneath it in the other view. So I've just brought the center of the football from the elevation down to the plan. So I know it's going to be someplace along there, but I don't exactly know where along that line it is going to be. So what I am going to do is get the football and just roll it around B until I have a plane view of this point of contact, or where the two of them are touching each other. So what I'm going to do, I'm going to get the radius of the ball and I'm going to step it out, and really what I am doing here, I'm showing the ball when it's directly in contact with the Sabutio figure. So that's where the new center is going to be of the football. It's going to be that far away from the hemisphere. So this is where the new center, so I've rolled the sphere around, and now what I've just found is the new center of the football. And that's if we could see both of them directly side by side. However, I can't, so what I just need to do is roll the football around the Sabutio figure. So I'm rolling around, and I'm going to keep on rolling around until I find the exact point where I want it, which is where the center is in the elevation, and of course it's going to be directly underneath it in the plan. So now I'm going to draw in the football. So I'm setting my compass off the radius in elevation. I'm going to draw the radius in plan, and what I have is part A completed to what the question has asked us to do. Again, good practice is always to show the points of contact. So to show the points of contact between a hemisphere and a sphere, or between two spheres, and it's going to join up the center. So that's the point of contact in plan. And the point of contact is going to be directly above that, up to the elevation. Again, simple orthographic projection principles. And it's going to label P in both cases. It hasn't been asked for, but again, good practice will always show the points of contact. So part B asks us to put in a new sphere, or a new football, and the diameter of this new football is going to be 20 millimeters. Again, it's going to be resting on the ground, so it's resting on the horizontal plane, and we're told it's going to be someplace over where C is. So the easiest way to do this is I'm going to forget about the hemisphere in the first case and just deal with each one independently. So we're told if it's a diameter 20 millimeter sphere, that means that the radius is going to be 10 millimeters off the ground. So I've measured up my 10 millimeters, and I know the center of this new sphere is going to be someplace along there. So I'm forgetting about B, I'm forgetting about the hemisphere for now, and I'm just going to deal with this new sphere in contact with A, so in contact with the existing football. So I know where the center is going to be, and all that I'm going to do is I'm going to just add on radius 10 millimeters onto my existing sphere. So now what I've done on that point, I found a sphere diameter 20, which is in contact with A. So I'm going to set my compass to radius 10. I'm going to draw in this new diameter 20 sphere. You don't need to draw it, but I am just going to draw it in. So this is sometimes referred to as a phantom sphere. So it is here for now, but it is going to move around. So that's where it is in the elevation. And now I'm going to show it in contact in the plan. When it's in contact with A. So again, I'm just going to deal with the center. I'm going to bring down the center. So that's where it is down here. And now I'm going to plot every single point of where this new sphere will be. So I know if it rotates around A, now what I'm doing, I'm plotting every single point. It could be all around there. So now I'm going to forget about A for now. I'm going to concentrate with B. So I know where the center of the new sphere is going to be. It's going to be radius 10 millimeters up off the ground. I'm going to step out 10 millimeters off the existing hemisphere. And now what I have found is a sphere which is in contact with B, and it's also in contact with the ground. And that is the center of this new sphere. I'm not going to draw it in this case. But if it was, that would be in there. It would be in contact with the hemisphere and also contact with the ground. So it is a phantom, as in it is going to be moving. So that's where the center is in the elevation. This is where the center is in the plan. So now what I'm going to do, I'm going to roll this new diameter 20 sphere around the hemisphere. Now what I have found, where it is in contact with B and also where it is in contact with A, where those two meet, that's one of the positions where the diameter 20 sphere is in contact with A and with B, and I can draw it in there. It does go under the ball and the hemisphere, so the hemisphere and the existing sphere, but that doesn't matter because if we look up in the elevation, so it just looks like it's underneath it. So that's actually going to be hidden detail, because if we look up there, if we're looking straight down, the new diameter 20 sphere is going to be just underneath the old sphere, or the sphere we've already been given. So again, I can draw in the points of contact, but I'm going to join up the center. I'm going to join up the center of the hemisphere. It's going to be someplace along that line, but where is it going to be along that line? I'm going to go back to when I have a true view of where they're in contact. That's where they're in contact there. And I'm going to bring that down. So I need to bring it, sorry, no, I need to bring it all the way down to the existing. I'm going to bring that around. So point of contact, brought down when the both spheres are side by side. I'm just going to rotate that point around. And we would do the same thing with B. And that is 2014 A4 complete.